same thing. So when I mean science, I mean all the disciplines in life that utilizes the scientific processes. So it could be anything you're doing. It could be official. It could be something you're doing randomly in your room or at your workplace or on your job. All of these are scientific processes. And in most cases, what we would want for a smooth life, probably is to have a process where you have an input and you have an expected output. So you put A and it's defined as when you put A into a process B, you always get C. And this is this is expected, or this can be obtained when you have a deterministic process where things have been done and we know that once you put salt into water, it gets salty. Or once you put sugar into water, it tastes sugary, things like that. But how much sugar it turns to, how much salty it turns to, we might not know. So except for a controlled experiment, it's going to be very difficult for us to know that once we put something into a different process, at the beginning of our iteration, we are going to have a certain output. So this is the major reason why we do science. So in most cases, what we have is not deterministic. So we have an input. For example, if you put fertilizer on the soil, what impact is it going to have on yield? You have an experiment you conducted, you have an output, you say one, you do another one, you have a different output. And if we have multiple outputs, by imputing the same input, what use is it going to be for us? If, for example, you go to the pharmacist, you buy a paracetamol, someone took paracetamol, he became blind, another one took paracetamol, her headache got healed, another one took paracetamol and he or she becomes dumb, for example. Then you have widely outcome for just a simple input. So we want to aggregate all this information in a way that can be used for our own benefits. So we have to make progress in life. And so we have come up with a way of analyzing our data. It could be through different methods and different processes. So I'll give an example, which I have already given. But if, for example, you have an experiment, you gave your turkey, or let's say hen or goat or sheep or cattle or human beings, and you have like a change in weight. For example, you have a treatment A, treatment B, and you have, let's say, Delha is selling some feed, and I am selling another feed, different kind of feed. Or in Nigeria, we have like Sunseed, or we have different kind of companies that produces different kind of feed, and you use this feed from different companies to feed your animal, or turkey, as this case is representing. So what is going to guide you on which of them to choose? So, for example, you have this feed from these two different companies, and you give to your turkey, and maybe one of them is not even mostly available. Probably you had to go into different processes, meet different people, make different phone calls to get this feed. And at the end of the day, you see that the difference that you find is not even as much as you thought. So is it worth it? So you might have to begin to ask yourself, maybe the feed you put in, they are made of the same components, the same things. Was the difference based on fluke? Maybe it's just random. Or if, for example, there's a weight gain of, let's say, 2 pounds or 1 pound, is it worth it to spend that extra energy to get the feed that you went to get to have this extra weight? So these are the kind of questions we try to answer in statistics, and it's cut across all facets of our endeavor: computing, agriculture, medicine, engineering. We have similar questions that we want to answer in this way. So, and R is not the only software for analyzing data. We have other software. We have SAS, SPSS, we have MStatC. We can also even do it on Excel. You can also do it on manually, even with our hand, we can calculate different things statistically. We do this in undergraduate classes and maybe graduate classes too. But people have come together because of the explosion in knowledge and the need for us to have what we call a reproducible results. People came together to develop some platform where, regardless of where I am and where you are able to apply the same codes, the same on the same data set and have the same results. So, and that's where we are today in respect to R and other software which are coming up, depending on the discipline you are. You have different open source software like that. So R is a computing language and an environment, and I will not spend much time here. It was developed in Auckland, and since 1997, we have a core team which developed R. You can on your own also develop some codes and also post to these groups. And it consists of a series of packages that are used to run a wide range of generic statistical analysis and many discipline-specific analysis. So there are some things that in R that everybody uses to develop their own specific package for their own analysis, as we will see as we move on. The good thing about R is that it is free, unlike maybe other software like, I mean, some are having some free versions now, but traditionally, software like SAS, not to demarket them, SPSS, to have a full control over what you are going to use it for, you will have to pay for them. It's not open, it's not free. You even if you have a free version that you are using, you are limited in what you can do in those environments. And if you can do that, sometimes this code that you are using is not available for other people to use, or other people don't have free access to those one you have. So it becomes very difficult for us to do research that can be confirmed by our fellows in different parts of the world. So R is free. It is open source. Open source means the codes that were used to develop R is available on the web. You can always download it. You can always change it to fit what you can manipulate it and come up with something new that is relevant to the community of scientists. So that leads to the next point, which is access to new and cutting-edge analysis. And the good thing about R is that every day people are making a lot of contribution on the web. Sometimes all you need to do to run R, sometimes most people do R as self-taught. Some of us maybe are lucky to go to schools where R is taught in classes. But again, in some places, you can easily teach yourself how to use R. It is so easy that once you do it, you can even be more proficient than someone who attended the classes for R. And eventually, you find yourself writing codes and functions in R. So what can R do for you? As we had said in the prelude, you can handle and format large, even small data sets, and you can do a lot of calculations, matrices and arrays and basic calculations. And there are a wide range of packages that are in R that you can utilize for your own data sets, regardless of which field you belong to. There are a wide range of packages in each field. And one more important thing, if you are in the lecturing field or academic field where you have to publish, or research field, you can easily, instead of going to maybe going to Excel, not Excel now, PowerPoint or other graphic manipulating software, you can easily, you will find out how easy, maybe if we have sometimes to have a session on how to produce graphs in R, you find that it's so easy to produce an advanced and customizable publication graphs in R. It's so easy, and those some of the big graphs you see online or see top people producing are just in R, just simple scripts, and you will run you'll find very interesting graphs in R. So how does the R work? So I'm not sure how this format is, but I think if we have to have some practical classes, which is a part of this presentation, I would want everyone to go to this website if you are with your laptop or desktop and try to see if we can download R from this page. If we need to go through to see if all of us have it, we can go through after when we get to the R session properly. And once you download the R, you can also go ahead and download the R Studio, which is more preferable to work. I mean, it's easy to manipulate your analysis in. So you can try on your own now and go to R and download it and try to install the executable file. And after you finish that, you can go ahead and install this one. But if you can't do that, we can also do it when we go into using the R proper. But try on your own if you see if it's possible. So CRAN, Comprehensive R Archive Network. Sometimes different locations have different needs for different type of packages, and mostly in different, as it has evolved over the years, many countries have, or countries or even institutions have sites where they have these servers and packages and documentations. And in most cases, you can use anyone and you'll be fine. But you are maybe interested in using the one that is closest to you, especially because you can easily access that CRAN. Then the R has a command line interface to import data, install packages, and run analysis and make graphics. We'll see that as we go on. So what are packages? I mean, I called packages several times. I mean, package is so simple. It's like anything, like just a set of functions that you can always implement with respect to a particular topic you want to analyze. So if, for example, you want to find a median of data, your function has its median, and the argument is your data, and you can go ahead and do that. In most cases, you have these packages in R that is utilizable by every field, and you can adapt it. I can even modify it for your own uses. As we will see very, very soon. So the best way to learn R is to do R. I mean, you can speak till tomorrow, and it's going to be difficult to us to visualize whatever we are doing. So people say, teach me and I will know, and tell me I forget. So in most cases, the best way you can learn R is to do it yourself and continually improving yourself, even beyond the classes that you have, else you forget most things that you've learned in the classes. So I don't know if we should stop here and go ahead and install R, or if we're just listening for most of us just to get a feel of it. But again, if you have gone ahead to install the R and R Studio, you will find that the R Studio has four different environments. For R itself, it has 3, but for R Studio, which is easier to work on, it has an added session, which is this script editor, where you can easily manipulate your data here and also enter some functions here and see your results as you're working in. I can also work here also if you want. And this global environment, sorry for the O, is where all the things you are doing will be shown here. And the plot window it's not a plot window per se, because you can also do many things in it. And it shows you the results of whatever you've done in terms of basically graphs in most cases in this area. And here I showed some basic functions in R. Again, it is better if we do it on our own in the R system, which we are going to migrate into very soon. This are available for everyone to use for their various analysis, and it is not specific to any discipline. And so getting yourself familiarized with this is very helpful, because in the long run, you are going to use it to explore your data and other things. And also we're going to show ourselves very soon how we use this logic operators, less than, and so on, as it appears here. But before we go into the R proper, I think it's good for us to know the basic data types and the data structures that we have in R. So your data types could be logical, true or false, numeric, as we know, 1, 2, 3. It could be integer, it could be complex data, and it could be character, maybe even ABCD or whatever it is. These are very useful, as we are going to see very soon, because it's something that we need to get familiarized with in terms of what we do almost every day with R. And the data structures, I mean, depends on how you look at it. Some just focus on vector and give the different categories of vectors in R. And some, I mean, for the most part, I would say there is most of the basic data structure in R is a vector, where you have elements assigned to a variable. Then data frame, you can have a column and also assign values to each of the elements in the column. And you can also have it in terms of matrices. So we have rows and columns, and you have your data sets in matrices, or it can be in list form. If you want to have more insight into this, you can go to this website, but we're going to have a feel of it very soon. So I would want to move into R now. I'm not sure if we're able. Sorry. If we have the R installed on our system already, or I'm just gonna present it and you can go ahead and just watch, and maybe you can adapt it to your own personal work in the future. So I don't know how the format of this webinar if I may ask Dalha, are we expected to come with our laptops, or just to have just a feel of it and just? Is Dalha here?
Yes. I think what we will do is just to go on, because some of us, I think, are joining using tablets and phones. So it's better to just run. Maybe in the next session we can prepare ahead of time, inshallah.
Okay. Can you see my desktop with our studio?
Yes, we can see that.
Okay. So I shared this scripts with Dalha. I thought we are gonna have our own computers to work with and just to follow what I was doing. But if I'm just going to work on it and just show all the basic things that we need to do, that's also fine by me. So, as I said earlier, the R Studio has 4 sections where you have the scripts, and this is the console, and this is the environment where you have whatever you run in terms of it appears here. And this is the plot section that I said earlier. But again, you can also use it to install packages, as we might see very soon. So here, sometimes there are already installed packages for you to use, the basic packages you need to use for your research. In most cases, they come pre-configured in the one you installed on your laptop or desktop, as it may be. So the packages here are meant to help you to be able to run some basic codes, and that will make your life easy. Then if you want to install, for example, you can use this. As I said, we have different crans, and if you want to install a package, for example, you can go here and write the package you want to install, and you can choose, you can go ahead and click on install, and you're going to install it, but that is not the point for now. Here we have different headings. We have this is basic things we do with R. All programs, you have file edit code. But the part that I want to just show us here is under the tools, you have your global option. And you can also customize how you want your R to appear. Maybe sometimes you want it to be like this. Sometimes you go on the web, you see something like this, different color lines. You can go ahead and customize it to the best way you want it to appear. And I think it's useful a lot, because some of us have different color ambience, and we might want to explore that. Another thing that is very important in R mostly is maybe setting your work directory. You can mostly, if you have your file in a directory, in a folder, and you open your R from that folder, all the things you do are going to be saved in that folder. But again, you can do it yourself by choosing the directory and save it to a different folder that you want to work with. That is very important. You can do it this way, or you can also do it in a different way of using sets working directory, which I'm going to show very soon. One important thing in R is how to get help. How to get help in R. For anything you think you don't know in R, there is probably at least 100 people have the same problem. That's the good thing about R. If you don't understand anything in R, at least maybe 10, let me be modest, maybe 10 people have had similar problems about R. So it is easy for you to go to this help and look for whatever you want to find, type any topic you're looking for, and if the information is available here, it's going to come up. Another way to look for help in R is to use the question mark this sign or symbol. I don't know how to use it. So if we want to maybe know what this function stands for, I just used one earlier. So if you're looking for what are the norm function does, we can easily do question mark and type the norm in front, and it's going to show us what it does here. This is not, you can use it for different types of functions and you get the same results. Help on that. Or easily, very, very easily, is to Google. Google has a lot of cheat pages for R. You can find them in Slack. You can find them on Tidyverse. You can find them on different platforms. Or even just random Googling, you will find out that somebody has done the same thing that you are asking or you want to learn about. So it is so easy. Then I have in the script, in the files I gave to Delha to share with us, I made one in script format and one in notebook format. So this is a script format where I have written everything in scripts, and you can, you have the same results if you go ahead and do what I have here. The only thing in this is that I have sectionalized these ones into different sections, and I can run just this section if I want, or this section if I want. And so I don't have to override what I have done before. So most people use the scripts version, but I prefer sometimes to use this, especially if you have a lot of things going on. And you don't need to run everything all over. You want to run on most of your analysis in sections. Maybe you have a big chunk of data, you want to know the median, but you don't want it to be overridden once you run a different set of functions. So you go ahead and probably use a notebook. But again, the script is the same thing, gives you the same results as the notebook. So I think we should just go dive into what we can do with R. You can use R as a calculator, 1 + 1, for example. If you do Control Enter, 1 + 1 will give you 2, as you can see in the console here. If you do alternate enter, you have the same results, just that your cursor is on the same line. But if you do Control Enter, your cursor goes to the next line. Or you can just run here, there's a run here, which you can run. So whatever you do, so you can add different things in R. But again, sometimes you want to store these variables so that you don't have them standing alone, and you can recall it anytime you want to recall it. So for example, the 1 + 1 we had earlier, we can store it in a variable which I have called GEMF for GAMG, Education and Monitoring Forum variables, and have it in this format where I have stored this same 1 + 1 I have here, where I have stored it in this variable. Next time, if I want to use this to call the 1 plus 1 I had earlier, I don't need to type the 1 plus 1 anymore. I just call on the variable and we have our results. So, and what it does, it gives me more room to manipulate my data. So if I have the Gamgee variable, for example, and I want to add or subtract or divide by it, is easier for me to not to retype what I have written earlier and just get my result. I mean, it looks simple this way, but imagine if you have like 1,000 numbers that you have to add and add and add. So if you have them, you can just store them in a variable and just continue manipulating this way. So if I want to add one to what I had before, easily, I write my Gamgee variable plus 1, and or you have Gamgee variable. You can also use maybe equal to, or you use the less than sign and dash. But mostly you have the most preferred format is to use the this combination. So instead of having, you see 2 plus 2, you have 4. You can also go ahead and do different things that you want to do with your. So in this first one, there are numeric. I didn't say it earlier, but there are numeric values assigned to this variable. But also you can also have maybe some characters in there and type whatever you want. So this one, I didn't something. I think I missed something up here, but mostly is this first one, this Gamgee variable plus 1 that is showing here as this one. So something mixed up here. I'm sorry about that. Then you can assign this same Gamgee order variable to the same variable that we had earlier. So what I'm trying to just demonstrate here is that you can assign anything to anything. You know, you can assign anything to anything. So if you have X, and if you have X and you have defined it earlier as a particular variable, you can go ahead to see if adding other things to that variable will make your life easier as you go on handling your data. Another thing you can see is if you have 2 separate variables that you have created and you want to see if one of them is the same or not equal to the other one, you can go ahead and do that. So you have this double equal sign means to see if it is truly equal to. I showed it earlier on the slide. So we had Gamgee order variable, we have Gamgee variable, and we want to see if Gamgee variable is the same as Gamgee order variable. And the what to construct in that line will be to use the double equal to sign. And once I do that, I see that the information is false because Gamgee variable is Gamgee variable plus 1, and Gamgee order variable is 2 plus 2. 3 and 4 are not the same. So, but if we go ahead and assign, and we say that Gamgee variable should be the same as Gamgee order variable, which we have done earlier. So we had Gamgee order variable as 2 plus 2, which was 4 earlier, and we want it to this Gamgee variable to now read the Gamgee order variable. We can go ahead and also assign it to it, and we have the same value as Gamgee variable now becomes the same value as Gamgee order variable. So that is how you can store your data in variables, and for ease of recalling of whatever you are doing. So I talked about the vectors earlier, and we want to know how we can create numeric vectors, for example, which we will have done in the process of explaining earlier. But if we have like multiple vectors, let's say 3, 4, 5, 6, 7, 10, 8, 10, 11, 12, 13, and we want to maybe concatenate them and work with those values, how do we go about that? So this C, in most cases, C is available to everyone, and it stands for concatenation, and it's it helps to join elements into a vector. So instead of having them standing alone, you can now have them together, concatenated. So now with this C, you can work with this, everything in this bracket, because they are now going together as one, as the same variable assigned to X. But again, sometimes you want to look at a range of values. Let's say you want to see 3 to 8, 3 to 18, or 3 to 8, or 3 to 10. You can also do that. And it's going to give you all the values from 3 to 18. So you can do it this way. You can go ahead and type print while you already type your X, and it will give you the same results. But this is another way of doing it. So you have, in this way, you can also do, if you want to write 10 to 11, or 10 to 100, or 10 to 1000, it's going to give you the same thing. You can try them on your own if you have the RStudio and you have the same results. It's best if done interactive, but if I have to just show it, that's how it's going to be. Then sometimes you want to have data, but you want to show those that increase by a particular value. So imagine you collected your data from different experiments, but you want to see the ones that increase by a certain amount. So you see the sequences. So here, if you do seq 2,4 by any amount you want to put, if it's 1, if it's 2, if it's 0.5, you're going to see that. So you have 2.0, 2.5, 3.0, 3.5, and so on, up till the last point you put here, which is 4, because you began with 2 and ended with 4. But instead of doing print, you can also go ahead and do your seq 2.4, and it will give you the same thing. Then if you want to repeat a vector several times, you can go ahead and do 1 to 2 and put the number of times you want it to repeat, and you have 1, 2, 1, 2, 1, 2. You can make it 10, you can make it whatever you want, and that's how to create a numeric vector. And there can be different versions and different types, and as you run across examples to use, you'll find that, or you can Google to see different types. So another one that we use often, because of our nature of our analysis, especially in the biological sciences and social sciences, and let's say medicine and agriculture, for example, we use mostly a lot of numeric variables and numeric character vectors, and also character vectors. So a feel of this is, if you have just the same way we had for the numeric vectors, you can also have the same thing for characters. But in this case, in character vectors, you have this double quotation mark for each of the character. And so if you do that, you have a list of letters. Then you can check the class of you have in your list of it's very important. We will see, if we have maybe other workshops, how these are important, because eventually you want to explore your data to see the different classes, the unique things in your data and other things. So these tools are preliminary, but they are important as you move on in your data analysis. So, but this is just to give us a feel of what you can do with R and the basic functions that are available in R. So if you want to see the class, you see that it is characters. If you want to see the unique characters in your list of letters that you've written, you have these: A, F, W, A sequence, and Neil's cell gauge. So in essence, it gives you what are unique in your character. So if you have multiple characters in your data set, it's going to give what is unique using this function. Then if you want to look at the levels in your character, it's not going to give you, because for you to have this information from a character vector, you will have to convert it to a factor instead of a character. And what that means is instead of just going directly like this, you have to use a function they call as.factor to convert whatever you have here into that. And now you can go ahead and do the same thing, unique. Do this, look at your levels, and you find that you have different levels in your data set. Then if you want to look at so this my special list give the same information as also the class that you want to look at earlier. So the next thing is how to get the same vector, which I have shown earlier, but I just want to look at if you want to have getting the same vector, there are different ways you can get it. I've shown different ways earlier. You can write it out full in this way. You can write it like this, and you have the same thing, 2 by 6, 2,6 by 2. You have it will give you the same vector, 2, 4, 6, as if you wrote out fully 2, 4, 6. Then you can also try to merge two vectors. So imagine you have a variable stored in X. So you have 2, 4, 6, and you have another one in Y. And you want to have this combined together. You can do that, and you have your X and Y combined together. So in that case, you're going to have the structure of this there. You're going to have 2, 3, 2, 4, 6. The first 3 you have 3, 7, or you can arrange it 2, 3, 4, 6, 7, as the case may be. So in that case, instead of working with this X and Y separately, you can go ahead and add other things to the combined vectors you already have. And if you want to add X plus Y, it is very important for you to note that in some cases, in the way R works, that it uses the values in each of this to complete whatever is not there. So for example, we said X plus Y, we have 2 plus 3, we have 5, 4 plus 7, we have 11. But how do we get 9? It went ahead and began from the first one. So we have to be very careful if we are using vectors that have different number of variables in them. So if, for example, you have 3, it's most advisable to use that. Or if you're going to use them together in terms of addition and the rest, you have to maybe make them into matrices and see how it works, which we're going to come to very soon. So all these are different ways of expressing, of looking at your data. These are very preliminary, as I said, but it gives you a feel of what to expect once you are working on your own real data. So it gives you that feel. So that's what we are trying to explain here. The same thing that we showed earlier, we can also do the same thing in combining numeric vector and character vector. But again, in that case, you are going to force whatever you have to work. So you have a numeric vector, you have a character vector, for example, and you want to combine both character and numeric vector. It forces it to appear as character, even though the A was not a character, but this was a character vector. So in that case, if you want to add anything to that, it's going to give you error result, because vector cannot be added to the character. The numeric vector cannot be added to the character vector. Then matrices, you can have, as we've been showing earlier, our A, X, and so on. We can have them combine two vectors in the same length into a matrix if they're of the same length. And we have rows and columns for our matrices, because we have 2, 4, 6, 2, 4, 6, and we just assign them to it. What we want to do, this is our X, and this is our A. So what we just did is to combine both A and X, and we have 2, 4, 6, 2, 4, 6, and into rows and columns. And we can look at the dimension of our matrix. If it's number of rows versus number of columns, here we have 3 by 2 matrix. And we can also combine different the same thing, different columns and different oh yeah. Yeah, the same but different column names. Instead of having X and A and X, you can have different column names and different row names for them. Then if we want to also combine X and Y to reuse them later, we can also do the same thing. But one thing we also run into is if we have number of rows of results is not a multiple of vector length, say true, you can have run into this warning signs. Sometimes these warning signs are just there to guide you, but it doesn't mean they are errors, but it gives you what you to expect. And also, you can have combine the vectors as rows. So what I did earlier is to just give whatever this function does, I try to explain them in the hash sign here to give you what to expect if you run each of this. So I'm just trying to repeat what is already there, but that is basically what we have. So I would want to move on to briefly, because I don't know how much time we have left, to see some of the tools we use. I showed this earlier in the slide. I just want to show what we can also do with them. For example, if you want to check if some of your operations are true or false, as I showed earlier in this slide, you can also check them here. If 1 is greater than 2, we already know that, but again, sometimes it is not just merely 1 more than 2. Sometimes you can have a lot of data in one variable, and you want to see if it's more than the other one. And it's, in that case, you can use that this to show. But in this simplest form is to just see if this 1 is more than 2. So which you can adapt if you have, let's say, M, and M is 2000, and you have X in your data file, and X is 500, and you want to see if M is more than X, you can use this to show that. So the same thing, if 1 is equal to 2, and if 1 is less than 2, I mean, we already know that, but as I said, these are the simplest forms. You can have very complex forms to demonstrate what you want to do. The other thing is to see if 1 is not equal to 2. So this sign is 1 is not equal to 2. The exclamation mark plus the equal to it stands for not equal to. So as I said again, it's simple in this way, but again, if you have large number of data sets and you want to see at what point one departs from each other, you can easily call them from your data sets to check this, to explore your data. So in all this, is better if we do them together and we run into problems and we find our way of solving them. But as this is introductory, and we hope that at least you get the basics of what you're trying to say. And if you have any questions, you can always ask. Then I'll just go briefly over how to randomly look at your data sets. You can do a lot of things in R once you have a data set. This is not our data set. This is just randomly created data set. To do that, you can just do set.seed. Set.seed is a function that makes you to work with different random numbers. So for example, I can do set.seed, and I can just call random numbers of 500. I can change this. It doesn't have to be 500. It can be 400. It can be anything. And I want to look at if to select a random numbers of normalized data from this same set.seed. This, I use firmness here because I work on Apple, but you can use different things. It can be weights, it can be egg sizes, it can be whatever you want it to be. But in any case, it gives you this random number from this set of number you have called to see, just for you to be able to explore without having to import data, because this is not the focus of today's lecture. So if we have we get random number of 400, or let's say 300, or let's say 200, whatever we want. Actually, it's possible. We can get 300 and I define, and I get different random numbers. But this is just meant for us to be able to do some exploratory data analysis in R. You can go ahead and put any number, you will have the same similar kind of thing. So if I want to look for the mean of these values, imagine these values are probably the weight gained after eating particular food, or the firmness of apple after applying some treatment, or the disease ratings after applying some chemicals, or some anything you can think about. So these are just random numbers that we were able to generate for just to explore our data. If you want to look at the mean, you can just go ahead and type mean. Mean is common to everybody. You can just type your mean and enter, and it gives you the mean of all your values, as big as it is. So you can have 1,000 and so on. So it's so easy. You don't have to. I know we use some of those that knows how to do other SAS and other things and other programs. It could be also easy for us, but also we know that previously you have to write some codes in certain places and implement them. But here, once you type in, but I mean, any program that you're used to is easy for you to use anyways. But if you type in and the firmness, you get your result of the mean. If you want to see the minimum value in your random data sets, imagine you have gone outside to collect data and you want to look at, what is the minimum value of in a particular group or in a particular data set. You can easily find that. You can also look at the maximum value. So imagine we take all our time to look at all these data to see which one is the maximum value. But easily, we can just type max and our data on our data, and we're going to have the maximum value appear to us here. And we can also look at the summary. So instead of typing minimum, maximum, it gives, if you type summary, you're going to get minimum, you get the first quarter, median, mean, maximum, just the same thing we had here. So if also in our large data set, this is a random, I'll keep on repeating, this is a random data set that we have generated. So if we want to look at the ones that are more than 14.07, for example, so we can have this, and so it gives us the firmness that is more than 40.07. So imagine you have a large data set, again, from your data collection, and you want to see which is more than a particular value. You can easily do that. So you can also sample the same thing, which firmness is greater than the mean of the firmness. So I need to give you all these values also. And you can construct different things as far as R allows you to be able to explore your data. So it's good for us to get ourselves familiarized with this, because before you go into deploying packages to run any particular set of data sets, this is what is going to help you to be able to really come out with certain things that will make you to see if what you've run is okay or something is wrong somewhere. If, for example, you have run your mean before and you have 14.07, and you are looking for data that is more than your mean, and you find 13 inside, it's easy for you to now kind of say, no, this is wrong, or this is okay, or this is something needs to be done, or you need to do some manipulation somewhere, or go back to your raw data file and see what you have input differently. So this helps you to explore your data sets. So which is what the major focus of today's webinar is, just to get ourselves easily familiar with what we are talking about. So that is that's for that. We can do different kind of things with them. The same thing. Look, if you want to look at the one that's lower than 10, and different kind of exploratory analysis that we can also do with our data set. So basically, we can ask different questions from our data set. So instead of doing the set.seed, you can also use what we've said earlier and generate some random numbers also using the seek function, because we used seek earlier. So if we want something from A to B, we can use the seek function to tell us we want something from 1 to 100 or 1 to 1000. So the same thing applies to this one. You can have 0 to 5500 and so on. In that case, our mean, for example, for this, if we want, after we have brought out this our number, we can also go ahead and do the same thing that we've done earlier on the data set. So we can find the mean, the sum, the standard deviation, and other things like that. So some functions like the standard error of mean might not be available in R, but you can easily impute that because you know the formula for doing that. So I think I've gone past my time. I'm supposed to speak for 45 minutes, and this is 8:27. I think I should stop here. There's always things to talk about in R, but this is just to give us a general feel of what we can do with R. And to me, I prefer to do it with everybody so that as I'm doing, you are doing, and we see where we go wrong, we see where we get it right, and eventually we learn together. And we also learn how to iterate and look for where we can find solutions to problems that we come across on the R platform. So if, for example, we run a script and it doesn't work, or a code, it doesn't work, we can always go to Google, check what is wrong. There is no shame, no shyness. All of us are learning. You can always Google, ask questions around, check Slack or other Tidyverse or your R help, and you can always develop whatever you want to develop. So in essence, this is just like an overview of what we can do with R. And there's a lot we can do with R. And not even a 1-year lecture will cover everything. So hopefully the platform continues to give other people the chance to present what they know from the R, from their R background. I would like to stop here, and if there are any questions, I would like to take any questions. Thank you.
Okay, thank you so much, Dr. Ojanova, for the wonderful presentation. I believe by this presentation, we are now familiar with the basic introduction of RStudio. And when we download the software, I believe we can get it more clear, because as we practice, we may be able to get more out of it. I believe there is need for another seminar which may require the practical session, and we will look into that and organize it as soon as possible, inshallah. And for the R group, we'll try to create the R group maybe on Telegram, and we'll share the link so that people can be able to join, and the discussion may continue there after the seminar. And for now, I think if there are questions, maybe we'll go ahead and take the questions. You can just raise up your hand and I will let you in for your questions. Or maybe you can also use the chat box for the questions. Thank you. Okay, Abubakar, you can unmute your side and ask your question.
Yeah, thank you very much for the presentation, Mr. Presenter. My question, can you suggest some books that we can go and look for to guide us regarding this software app?
Oh, wait. Okay. Thank you for the question. I mean, you can get as many. I mean, R has a lot of. There are a lot of books on R. Some are available freely online. Some are not. What I intend to do is, I mean, I slept off, but what I intend to do was to upload a file onto my GitHub page uh, that has some resources, including what I've shown today, so that you can always go there and download and use. And hopefully I will include some documents in that file. But they are, I mean, it's to me, books on R, I mean, I wouldn't want anybody to waste them. I must have waste money, but I wouldn't want people to buy books for R to me because you have a lot of resources online for R. You know, there are a lot of resources. Once you Google anything, you find, and there are several R groups. If you are on Slack, you will see a lot of different R. I mean, it's everyday stuff because if once you buy the book, it might be fanciful, but R keeps on improving. So there are books on R which you can go, which I can put some of them in the file. And for some specific industry or discipline related uh, uh, analysis, you will find R codes for those words. That is where it is important. But if it's for the general R platform on how to use it, my brother, I mean, everything is online. I mean, I would say everything is online for the most part. The only thing that you can, if it's something that is unique to engineering, unique to plant pathology, unique to animal sciences or pharmacy or medicine, then yes, people have that discretion to make it available to everyone or to commercialize it in their books. And in that case, it will be discipline specific. So I wouldn't want to recommend any book off the top of my head. I think Google is a big friend on R. And I think the different platforms which are shown in the tidyverse, the R groups, somebody just shared our Telegram R group and so on. This is available. I mean, these are the places to get our stuff to work with. So, and the good thing about R is as you use it, you get used to it, you get more information on how to use it, and you become adept at it. And you yourself can be a book on R. I think so. So I believe that I wouldn't want to recommend any particular book per se, except if it is a discipline. If you say, oh, is there an R book for phylogenetics? Maybe I can recommend for you, but or an R book for some things in R in engineering and telecoms, maybe there's some books for that. But for the most part, what you need to do with R is online. I can guarantee that.
Okay, thank you so much, Dr. Ojonoba. And Jackson was asking if you will consider biological science people in the next seminar. I believe the focus is science-based, so it's something, it depends on the need we have for the R software. But I think we are taking the basic introduction. The application depend on our individual fields, right? Then
Yeah, I agree with you. I think that's mostly left to the ESCOs at the GAMG forum to probably organize certain our webinars and invite several people with several skills. I believe that there's a lot of people, tons of skills in different disciplines. If you call me to come and talk on engineering, I might not be able to do that. But if you call me biological sciences, life sciences, probably yes. So so there are tons of skills that are available, and I think it's good to invite specific people in those with those skills to come and give those thoughts.
okay. Thank you. Then Dr. Daudu is asking when would the next, how would they know about the next meeting or the next seminar? I think we just created our group on Telegram. The link was is shared on the chat box, so you can easily join the group, and from there we'll communicate once we have a presenter. Then I think Mohammed Adamu, please, you can unmute and ask your question.
All right.
Okay.
Thank you very much, Doctor, for the presentation. The question I want to ask is this, because I've used latex, so I want to know, is there anything similar between the latex and the R? Because it seems to have similar templates here.
Okay, yeah.
Can you hear me, please?
I can hear you.
Okay, go ahead.
Okay. Is that all?
Yes, I think that's all for his question.
Yeah, so it depends on what are you doing with I have not used letters, but I have similar questions last time in an art group that I was part, and not similar as yours, but you have this sometimes if you want to publish papers and they ask you to submit in different formats, and some ask for latex and other use different stuff. But personally, I'm not familiar with latex, and I'm much more adept with what I use. But I can't see. The person that was asked this question also said that they prefer to use R, but in a different context. It was in terms of image submission, yeah, not analysis, yeah. And the person was he prefers to use R graphics for submissions of the text. But I'm not familiar with what lattice does and what it stands for.
Sorry, thank you.
Okay, I think I saw Nura was raising his hand. Nura Hayamusa, you can unmute and ask your question. Can you hear us? So I think he cannot hear us. So I think I don't have any question now. Okay, let me check the chat box. Yeah, I don't think no any question left. So Dr. Ojonuba, do you have any further comment, suggestion, or recommendation that we can take? If not, I think we can round up the session.
I mean, there's nothing much to add, just to say that this is just a feel. The best way to understand R is to use R. And if you take the class and you don't use it, you forget it. Eventually, you're going to have your own set of codes that you use, and that's going to be what is most important. But let's keep the discussion going on, and let's have more people come around to give us talks on different skills in R. There is graphs, which is one of the most important, producing publication-ready graphs, or things that have to do with some software or analysis in different disciplines. To me, this is the most important thing. The other ones, as I've shown today, anybody can do it. You can always, these are the basic foundation just to have a feel with whatever R can bring. But I thank the Gamji Forum for inviting me, and hopefully we keep the conversation going. And if there's any time you need my presence, I'm happily available, ready to create time for anything you want to that I think I can deliver on Thank you.
Thank you so much, Dr. Ojonuba. I will now call on Buhari Muhammad for the vote of thanks to end up the session. Buhari.
Yeah.
Okay.
Thank you very much, Doctor, for the wonderful presentation on behalf of GAMGI and also on behalf of all the participants. We are really grateful for this wonderful presentation. And of course, inshallah, this is the first, which is the beginning, and subsequently, some session on R will follow as well. Also, thank you very much, Abdulkader, for coordinating this session, and we also thank all the participants for joining us in order to learn from our great doctor. The recording of this video can be found in GAMGI Educational and Mentorship Forum on our Facebook page, as well as you can find it in our YouTube channel, which is GAMGI Educational and Mentorship Forum. So if you haven't followed us on all our social media, you should do so that you will be in contact with all our activities. And also, inshallah, like we said, this is the beginning. So you need to be to keep in touch so that when there's gonna be next session, you will be the first one to know. So that's what I have to say for now. Thank you very much, everyone. Thank you, Dr. Mustafa, and thank you, Dr. Abdul Qadir.
Okay, thank you so much, Dr. Buhari. So I think that's the end of the session for today. Looking forward to seeing you during the next presentation. Thank you so much.